Okay, so we are doing a titration, and this is a colorimetric titration at that. First thing we want to do is make up our standard solution. So this is a volumetric flask. This is a 250 ml vol flask, and I've already measured my hydrochloric acid, which is concentrated hydrochloric acid. So I'm doing all of this under the fume cover. So I added a little water to my flask. Now I'm just going to pour out my acid into this. I'm not even going to use a funnel, which you could use a funnel, but this is pretty small, so I don't need to use a funnel. So I'm adding all my acid, as much as I can get. And of course to this you're using distilled water. Okay, so now I have my distilled water. I'm just going to rinse my measuring cylinder, and technically speaking you'd prefer to use a pipette for this, a quantitative pipette, but we do not have a quantitative pipette, so we're just using the measuring cylinder to get the volume. And we add that all, we try to rinse out everything, get it down in there, just rinse it again, just to get all the acid, to make sure that we're transferring all the acid from the pure acid solution. Then, if you can see here, there's a mark right there. We're supposed to fill up to the mark. So that's what I'm going to do with this distilled water. And of course you must read this at eye level. So I'm just pouring this in. So then we fill up to the mark. Here we go. We take our time. Almost there. Almost there. You go slowly. And of course I'm reading at eye level. It's not a rush thing. You have to be patient. Okay. It's at eye level. So now we're good. And this is one solution that we're going to be using, 0.1 molar hydrochloric acid. Okay, so we are doing a colorimetric titration. As I said before, there are several types of titrations. You have colorimetric, where you look for a color change. You have photometric, where you can use light changes. You have conductometric, where you look at conductance changes within the solution. You can have thermometric titration, where you measure the temperature changes. You can have spectrophotometric, where you look at changes in colors and absorbances throughout the titration. Of course, we have pH titration as well, where you measure the pH change in the titration. But for today, we are just going to look at a colorimetric titration. So I have all my apparatus here, I believe. I have my methyl orange, which will be my indicator, my pipette filler. When I was going to school, we didn't have these things. A filter funnel, your burette, your clamp stand, your pipette, 25 ml pipette, and of course we had our solutions previously. So what I'm going to do first is just check the color of my indicator in acid, so I can know what my endpoint color change will be. So I just add in a drop there. As you can see, changes something like red. Let me add another drop. There you go, reddish. And let's see what the color is in base. This is just to help us to determine what the endpoint is supposed to be. We add a few drops. Ooh, looks kind of greenish, yellow, something like that. Okay, right? So that's what we're looking for there. That sort of color change from a red to a greenish yellow color. I'm not very good with colors. Alright, so first thing you want to do is you want to fill your burette. And of course you should not be reaching all the way up to fill your burette. You can adjust the height of the burette, so you bring it to the edge of the table. Then you go back up a bit, make sure the valve is closed. The valve is open when it is vertical, and it is closed when it's horizontal. Alright, so you can adjust the height of the burette. You put your funnel inside, and we're going to put in the burette hydrochloric acid. So make sure the valve is closed. Lift the funnel when you're filling it, because if you don't lift it, what will happen is it will reach all the way up to the top and you think it's not full as yet. So just lift it so you know the exact amount that's in there. And I'm not going to fill it to a specific amount. I'm just going to allow it to go above the 0 line. That's all. It's almost there. Alright, there you go. Notice I'm removing my funnel. It's above the 0 line. And then readjust the height and allow it to flow, fill the tip. And now it's below the 0 line. I'm good to go. Can then now take your initial reading. And of course the birette is like a ruler which runs from 0 at the top, and this is a 50 mm birette, to 50 at the bottom there. So you can just read it just like a ruler. The increments are on it. So you take your reading, and of course this would be your initial reading. You record this in your table. If you do not record data, then going to a lab is not going to be very useful for you. You have to get results when you go to the lab. Now, I've done that. What I'm going to be doing now is pipetting my sodium hydroxide into my conical flask. So this is my Erlenmeyer or conical flask. So I'm going to pipette my sodium hydroxide into this. So I take this thing here, my pipette fill, hold it short, because if you hold it long it can break. So you hold it short and you simply fold it in. There you go. And then on your pipette filler you have S, which really means to suck the solution, and you have E to empty it. Right? And so what I'm going to do is just get the solution in here. And of course and as you can see, the solution is climbing up nicely. On your pipette above the bulb, this is the bulb of your pipette, and of course up here is the mouth, and down there is the tip of the pipette. So above the bulb there's a line which tells you where your 25 is supposed to be. So I want the meniscus to sit just on that line. Just on that line. And I should not have any air bubbles in my sample as well. So it's above it, so I need to now adjust the height. That's what I'm doing now by squeezing the E on the pipette filler. And the solution will run out slowly. There you go. So now that we have that, we can now empty our pipette into the conical flask.
Animation versus
Alright, then whatever is left in the pipette should remain in the pipette. So don't try to shake it out, don't do anything of that nature with it. And then I just replace this over here. Now I'm just going to add about 2 drops of my methyl orange indicator. Well, that was 3, but okay. Still can't see, so let me add a few more. Alright, great. There you go. Of course you wear a white lab coat so you can compare your colors to that. Now we're ready to titrate. And of course titrate means that I'll be adding a solution from a birette to a solution in a conical flask until I get to an endpoint in this context. And an endpoint is when I get a color change. And remember, we already showed you what the colors should look like. So here's the color of the methyl orange in base, and this is what it should look like in acid. So when I get to an acid, this is what my color should look like. So we now start titrating, and you must titrate with 2 hands, not 1 hand. You titrate with 2 hands. Some people prefer to turn the birette around and have the valve on this side, while others prefer to have it over on this side. So now we titrate. So my solution is being added to my conical flask, and I'm swirling continuously because I'm trying to mix the reactants together thoroughly so that they react, as best as possible. This can be automated using something like a magnetic stir bar, so you don't have to be swirling like this. Or there are other things that you could use to do the stir, but manually this is what we're going to have to do. So notice here I'm watching now the conical flask, not necessarily looking at the volume that is in the burette, because I'm trying to identify the color change at the end point. That's what I'm focused on. Okay, so I'm looking for it to change from that yellow greenish color to that pinkish color. Now normally you may want to have like a white paper under this thing so you can see the color change a lot better. But this is fine for now since I can clearly see it. Alright guys, if you found that video helpful, or if you find any of my videos helpful, and you are interested in getting this CSEC chemistry laboratory notebook, just send me an email, write it in the comments, something, so I can get in touch with you, or you can get in touch with me, and we can make that partnership. So this is a CSEC chemistry laboratory notebook, as you can see there. The cover page, your name, your school, all the information that is needed is there. And of course, this is a lab book that covers pretty much all of the units that you will do in CSEC chemistry. Here you have a table, well, not a table, but a page of the important constants and some important information and stuff like that, right? And then in your table of contents now, as you can see, the number of labs which are there, 36 labs in total in this edition of the lab book, right? Your skills topic, subtopic, state of matter mixtures, redox, acids and bases, volumetric analysis, planning and designing labs, electrolysis, organic, qualitative analysis, all the labs are there. The skills are being tested as well multiple times. ORR, your AI, your PD, your M&M, everything is being tested. The area for the grade is there, and it is just nicely laid out for you to use for your classes. So if you are a student who is not in school right now and you are doing chemistry on your own, at extra classes, and you want a lab book to use, this is perfect for you. And if you are in school and you're still using the hardcover notebook in terms of the composition book to write up your labs, or the lab book where you have to write every single thing, then this lab book will work perfectly for you, right? So you see, this is one of the labs here. You write your name, your lab number, the date, the aim. You can derive the aim based on what your examiner is marking for, and you have your background information. You have all of these things, your observations, which you can write up, your discussion, your conclusion down here, and you can add your errors and those sort of things. So the lab book is nicely set up for you to be able to do your labs very quickly, get it over with very fast, and lot less writing. And of course, this book is for 2 years. So, you don't have to be thinking about getting a second lab book. There you are. There you have graph sheets in there. So if you need to plot a graph, you can do that. Um, and yeah, this is for 2 years. So therefore, if you're interested, if you find the videos helpful and you need a book to do your labs in, then just drop a comment, send me an email, g2academy@gmail.com, or you can comment on the video, and I'll get in touch with you. Thank you. All the best. And remember, at G Squared Academy, excellence is epitomized. There you go. So you now have your endpoint, and you can compare that to your white surface. You can look at it. And so now we have reach our endpoint. You now take your final reading, so you adjust the height of the burette, and you read at eye level, and of course you record that information. And the rule of thumb is that you do, and then of course you subtract your initial reading from your final reading to get a used volume. And you do not, rule of thumb says, you do not stop titrating until you get values that differ by no more than plus or minus 0.10. Alright? So this is just our first titration. So we probably have to do at least 2 more for sure. Okay, but there you go. That's how you do your colorimetric titration.